thank you for joining. I have to use 2 computers for now. Okay. Just remind me if I did not switch the screen for you, just remind, okay? So please, try not to talk to your neighbor. Let's focus, let's try to finish. All right, guys, can you hear me over Zoom? Is there a question?
Yeah.
All right. So last week we discussed the first 2 layers. What is the first 2 layers last week we discussed? Can you remind me what we discussed last week?
What are the last layers?
So we discussed the first 2 layers, the physical layer, correct? And we discussed data link layer. So just want to go very quick. And as we said in the data link layer, we have that we discussed the Ethernet, correct? The Ethernet protocol or not protocol technology. And we said the Ethernet using carrier sense, collision detection, correct? Carrier sense, multiple access collision detection. And why we use this technology? Why we use the collision detection? What's the purpose of that? Why? Because we have a shared media between the source and destination, correct? And this media, multiple source can use it. It's not dedicated for one, source. So multiple source, they will try to use the share. So for any reason, if they try to use it at the same time and they send data at the same time, what's going to happen? You will have collision between the data. So the data will be colluded because now both of the destinations will receive mixed signals or data. And we're trying to first control the access. Before you send anything, you have to listen to the media. If it's free, okay, then go ahead and send. But if the media busy, you have to wait. But for some reason, sometimes, you try to listen to the media and you think it's free. And the other end or the second computer listen to the media, think it's free. And both of them, they send the signal or the data. Then what's going to happen? We'll have a collision. Now, how we can avoid that in the Ethernet? By what? I think it's here. Sorry, let's go back. How we can do that? How we detect the collision. So we cannot avoid it. So the only things you can do, you can detect there's a collision. And if there's a collision, what you have to do? So both sender, they have to terminate. And they have to wait, a certain time. Then they will try again to send the data again. So we cannot avoid it. So we can detect it. And we try not to send signal by listening to the media. But if you send and something happened, what you have to do? You have to terminate and resend again. So that's in the Ethernet. And what about the wireless? What we did? We're trying to avoid. So we're using different method. We use carrier send, multiple access, with a collision avoidance. So how we can avoid that? What's the mechanism to avoid the collision? I send in signal. So I'm ready to send data, to my neighbor. What I will do before I send, what I have to do? I will listen to the media. If nothing happened there, first thing I will do, I will send a signal to everybody around me. Tell them, I want to send. I will send a request or signal, what we call it, ready to send, correct? RTS. So when I send RTS to everybody around me, what's going to happen? Everybody listening, correct? All of us, we're listening. Now, all of us now, I'm talking, you listen to me. So what I'm saying now, I say,
Yes.
yes. All right, so I'm trying, I'm telling everybody around me, I'm trying to send something. Can I send? So I'm sending from A to B, and still C, D, E, F, everybody's listening. So they will know A, we're trying to send something, okay? And they know they have to wait, they cannot send anything, right? Yeah. Now I'm trying to send the B. B, what has to do? Send another signal telling me, okay, you clear to send. Go ahead and send me the information. So in this case, by sending the signals, I'm trying to avoid the collision. Is that guaranteed? No. So you're trying to avoid it, but still there is a potential it's happening. And one of the issue in the wireless, what's the issue? Which we call it the exposed node. So I'm trying to send it from A to B. However, C, it's within the range. So C cannot send anything, it cannot accept anything because I received the signal from B saying, no, don't send anything. So still there's a problem. You're trying to avoid, it will work, but it's not going to be 100% guarantee. So that's what we talked last week mostly. And the other thing we said about physical layer, what the type of data we send in the physical layer? Physical layer, we send a stream of bits, 0 1s. It's a stream. Okay. Now, what about the data link layer? What we're trying to send? Frames, correct. So what is the frames? So the frames is the whole message is divided to a small size of packets or frames because you cannot send a big message. You will overwhelm the network. So what you have to do, you have a big message, you have to divide it. There is rules, you have to know what is the rules. You divide it to small packet, you add headers, and then you send one by one. You send the frame by frame. However, the frame, it's going to come through the physical link as bits, 0 and 1s, right? So that's what we discussed last week, correct? So let's go chapter 4. What is the chapter 4 is about? Is about a third layer. What's the third layer called? Network layer. What is the network layer? Can if somebody give me tell me what is the network layer?
It uses like TCP and IP protocols.
That's a transport layer. I'm sorry, that's the transport layer. So it's going to use a protocol, but the network layer, it's in the top of data link layer for now. Let's talk about it's the layer on the top of the data link layer. And when you talk about the internet, so what we'll discuss in this, we'll see what's the difference between packet switch and circuit switch, and then we'll see what is the connection oriented and what is the connectionless. What's the difference between them in the network? And finally, we will talk about some of the issues we cannot provide at the network layer. All right, so how you look at the internet? The internet in general. So the internet it's multi-connect network. So you have a device A trying to reach out to device B. It's connected through LANs and WANs, and all these WANs, LANs is connected through connected device, either router or switch. Okay, and what we have to think about the internet, it's a black box. For me, when I'm trying to send it from A to B, okay, it has to go through a process. What's between A and B, it's just the internet. And think about it, just a black box. You don't know what exactly happening inside because there is protocols, there is rules managing the connection or the communication between the host A and host B. And how you send the message? The message simply is going to go through the layers. How many layers we have in TCP/IP protocol? 5 layers. So it's gonna go through these layers one by one, through the network or through the internet. Then it's gonna go back in the destination. It's gonna go through the layers from bottom to top and to reach the application. So what is the purpose? You have an application at the destination A, trying to send a message to the same application at destination B. Can you give me an example? Some of the application we are using these days? Your email, correct? You're trying to open your email. Is your email reside on your computer? No, it's a web application. You know, of course, there is a server. If you have if it's a local, stored locally in the server, but you have to go through, you know, the internet. So when you open your email and you type your username and password, how your email system will know that's you? So it has to send a message. So simply, you open the browser, you open the application, you know, the Google Chrome, or you open the IE, or you know, the Edge. You type the address, type your username and password. Then the message is going to go through these applications or these layers through the internet and goes up to the server. Then the same thing, the server will reply back through the same channel, you know, through the application. So the point here, trying to send a message has to go through all these layers, layer by layer. Each layer will provide a function to the layer below and to reach to the destination. So what we're talking about here, let's think about the internet as a black box. You know, I'm trying to send from A to B through the internet, and the internet do a lot of stuff for us. And we'll see how. All right. So, you know, that's a small network. Let's say, you know, that's a local area network. And you're trying to send something from A to B, and there is multiple routers. For example, you know, this building has a router, and that, you know, the IT building has a router, the library has a router. And I'm trying to send a message from A to B, or a data or packet, you call it, you name it. So it has to go through hub by hub. And your network or your internet here has to decide what is the best way to deliver the message. So each router will has a table. Based on this table, it's going to tell me, you know, if I'm trying to reach to B, I have to go through router 1. Unfortunately, actually, maybe I can use my mouse to write. Oh, actually, no. Oh, just remind me, guys, because I have 2 computers. If I'm not, I have to move. Just remind me to, if I forgot to switch the slide, remind me to switch it, all right? Okay, so again, when you send a message, you go from the top layer, go all the way down through the internet, then go to the destination from the bottom layer all the way up. Simple. So here in this slide, I'm trying to send a message from A to B. I'm trying to send a message from A to B through multiple hubs. So now your network, somehow it will be mapped. It will be mapped through unfortunately, I can't. Oh. I'm sorry, guys. Now, everything in this school is broken down. I'm sorry for that, but I cannot really help with that. So I'm trying to send a message from computer A to computer B. It's going to go through multiple hubs, and your network will decide, you know, what is the best way to go. Is the router 1? Let's say, you know, let's assume the first one is the router 1. The second one R2, R3, R4, R5. So your network, based on the implementation and the table or routing table, will tell you have to go through router 1, 2, 3, then destination. Okay. Sometimes, you know, you will have traffic at the router 2, then maybe you have to go through a different route. And based on that, based on your network design. So the point here, your data is gonna jump from hub to hub and find the best route to go. More of the route is more available and not busy, plus faster. So you always, the best way to find the shortest path. If you want to go to New Jersey, what is the best way, guys? So what is the best way to go to New Jersey? Highway, but which highway? 95 or 15? Not always. Sometimes when you put the address in GPS, ferry depend on the traffic. The ferry, if you're late, if the ferry comes at a specific time, if you want to leave now, that means you have to wait for half an hour or 1 hour until the ferry comes, correct? So the network is changed based on the traffic, based on the distance, based on even the hub. Maybe sometime you will have one of the hubs is down for a reason, it's broken, they do maintenance. So now the whole network has to communicate somehow based on the tables, how they exchange the data between the routers. Then you have to follow the best path. The best path doesn't mean all the time is the shortest path, because sometimes the shortest path, they have a traffic. Everybody using the short path, that's why you will have traffic. Usually 95 is the fastest. If you use the 15, usually it's long distance. But sometimes the 95 has a lot of traffic, then you have to change your route. You have to use the 15. Personally, when I go to New Jersey, the first thing I do, I put the address in the GPS. Because not all the times 95 is the fastest. Not all the times going through the George Washington is the best way to go to the New Jersey. So, and I prefer to go to the 15 because I know it's longer. However, it's going to be faster for me at the end. So that's the same thing for the network. Network, you will have routers, and the routers will decide what is the best way for you to reach out to the destination. All right. So again, what is the purpose here? To deliver the message. Your network to deliver your message, and make sure it will reach out to the destination without any issue, without any error, all right? And you're not missing information. So that's really the purpose. Now, what is the type of circuit or the switches we can, remember, think about the network as a switch. So you're trying to switch it from router to router, or if we need to give you the example about driving the car, you're trying to switch it from highway to highway. So using 95, but not all the times it will be. You have to jump to another highway. So 95, if you want to go to George Washington Bridge, you have to jump the highway 80. If you want to go through the Banzi Bridge, you have to jump in the 287. I know those because almost every week I go to New Jersey. So the same thing for the switch. Here we're trying the whole connection. It's a switch. You're switching from node to node. Nobody remind me to switch, guys. So you're trying to switch. You're switching your data from node to node until you reach a destination. What is the type of circuit we use to deliver the message? There is two, either the circuit switch and the packet switch. What's the difference? So circuit switch, which we are not using in the network. Circuit switch mainly is you reserving the path. That's similar to the old or the phone system. When you're trying to call, when you dial a number, okay, you dial a number to the destination, okay, the phone is gonna ring. When the other end answer, what's happening there? So you reserve the path, which means the whole traffic is gonna go through the same path, and nobody else using this path. So until you finish your call. After you finish your call, now the others, they can use the same path, So that's they call a circuit switch. You establish the connection on it, and after you establish it, you use it until you finish it. Why we are not using that with the network? Can you give me reason? Simple reason. Because at the network, you're trying to give service to everybody. If you reserve this channel or this path, okay, for a long time, that means the others, they have to wait. Nobody will be able to send data or receive data. So in this case, we switch it to the packet. Packet, you know, it's sending, dividing that resource and provide that to multiple source. So it's not going to be dedicated to a specific device or some person or entity. It's going to be shared between everybody, and it's going to take kind of turns, and use different paths. Because when you establish the connection in the circuit switch, even now it's fast. You think that's the shortest path. Maybe later it will, maybe there is another faster path based on the traffic and the network. That's why when you use network, that's why we call the switch, because it's switching from path to path to find the best way for you. All right, so physical circuit is a channel is established between the source and destination of the message. I'm sorry, before they deliver the message. So you have to establish the channel. That's the first step. If you want to go to New Jersey, I have to use the same route. Okay, you cannot switch, which is not going to work. You have to switch. So after you establish, then you have to send the entire message. You cannot divide it to small pieces. That's why when you call somebody, you have the channel until you say goodbye. That's when you finish the whole thing. So, however, in the packet switch, you're sending small pieces. All right. Okay, the circuit switch, as we said, we never implemented in the network layer. Okay, why? Because we need a shared resource. We cannot just give it to one person and a person control it forever. All right, so that's gonna be one of the questions in the exam. When you see a blue box, that's gonna be in the exam. In the circuit switching, the whole message is sent from source to destination without being divided in packets. We send the whole message, and that's why we are now using that in the network. Okay. We explained this example. We say as a phone system. Phone system, when you call somebody and they answer, you will have the circuit until you finish. Nobody else can use the same channel. Okay. Now, what is the packet switch? So packet switch, as we explained, mainly we divide the message, the big message, to small pieces and send one by one. And this packet, maybe it's going to go through different routes. I will say an example. Maybe it's kind of, for me, for example, I'm trying to deliver, I deliver, a car or parts of the car. Maybe, the first shipment, I'm sending, the wheels and the body through the 95 to New Jersey. Maybe the other entire material, it's going to go through the 15 based on how the driver decide. They want to go to 95 or the 15. Then at the factory, they will receive everything and they put the car together. They will put it together. So, however, you divide it to small pieces, you send it, and based on the driver will deliver it, which highway they want to go. But when they receive it at destination, what they will do, they will put the car together and deliver it to the end user. Who's the end user in this case? In our network, it's the application layer. So the network layer, the drivers, they will deliver to the factory. Factory will put it together. Then the goal to deliver to the customer. Here's your car. In our case, we will deliver the message to the application layer. All right. So the destination waits for all the packets. Okay, wait all of them together. Then what we do? Build the message, put the message together. Because remember, I'm trying to send I love a Bridgeport. I will send I in one packet, love in packet, Bridgeport another packet. But do you think I have to deliver I separate to the the application layer? No. What I have to do, I have to wait until all of them receive. Then I put them together somehow, and then send it to the layer above me, which is transport layer. Transport send it to the session send it to the application. So that's how the process happens. All right. Again, in the packet switching, the message is first divided into manageable packets. Thank you. Keep reminding me. So what we do again, we divided the message to small packet. Why we say manageable packet? Can you explain that to me based on the previous chapters? Remember when we talk about in the data link layer, we talk about how, the Ethernet, then we talk about they will move it to fast Ethernet, then 1 gig Ethernet, then 10 gig Ethernet. So can an Ethernet with 1 gig capacity can deliver something to a 10 gig? Yes, because that's what the reason why we say all of them, they can work together. Even if you have a laptop, slow laptop, still will be able to communicate with a fast laptop. Same thing if you have a fast laptop, which has a higher bandwidth, still can send data to the slow laptop. However, they have to negotiate. So I'm fast, okay? And I can send 1 gig data at the same time, all right? The destination can receive only 10 megabytes per second. So now I should send on my speed on the other end speed. The other end, because he can handle only 1 or 10 megabit per second. I can send faster, but since I know, the destination cannot handle more than 10 megabit per second, we have to communicate. So, I'm not sending in my full speed. I will send with your speed. So that's why the whole standard, when we talk about standard, because we need different type of end device to be able to communicate, even if they have different specification, different speed. Even not only that, even if you have a laptop using Ethernet, okay, which is the wire, and I have a laptop using a wireless, they should be able to communicate. That's why if we follow the standard, still we'll be able to communicate. So the question, why manageable? Because I don't want to overwhelm the other end. I want to make sure I divide it to a small packet or small frames. Then what's delivered to destination, the destination can handle it. Okay, so that's why we say manageable. You cannot send a huge data. That's why we divide it based on our environment. I know if I'm sending a packet to an Ethernet with 10 meg, I have to send 10 meg. If I'm trying to send something to 100 meg Ethernet, I will send 100 if I have the power. If I'm sending to 1 gig Ethernet and I'm can send only 100, then I will send my speed, but because I know the other end, they can handle. They have power than me, but they will handle. That's fine. So the purpose here, you divide your message to small pieces and you send 1 by 1. So that's the packet switch. That's what we explained, nothing special here. All right. So now, in the packet switch, we have there's 2 ways to send the packet. So we have something called connectionless service and connection-oriented. Can one of you give me a hint? What is the connectionless and connection-oriented? From your previous network class, maybe when you took it in the undergrad or grad. Connectionless. And connectionless. It's connected. You have to be connected to something. So the connectionless simply, and you send a packet packet by packet, one by one. However, you send it and you don't care which path has to go. You let the network decide. It has to go through router 1 or router 2 or router 3. So the network, based on the mapping or the routing table, will decide, let's go this path. So you send packet 1, 2, 3, 4. So packet 1 maybe, forgot to remind me. So I'm trying to send packet 1, 1, 2, 3, 4 from sender to receiver. So maybe packet 1, when you send packet 1, it's going to go through R1, R3, R5, then receiver, all right? Packet 2, okay, maybe which will go to R1, R4, R5, and receiver. So connectionless, you send as a sender. I send it, and I let the network to handle it, correct? Which is the best path. And when you send a different, when you send different packet and different path, there is a chance to receive packet 2 before packet 1. So you will not receive them in order because you don't know which path is faster, right? So at the destination, maybe you will receive the packet out of order. So for example, I'm trying to send a message from network layer. So I'm trying to send packet 1, 2, 3, 4. All right. So maybe packet 1, it's gonna go through router 1 to router 4. Packet 2, it's gonna go from router 1 to router 2. Now maybe packet 4 and 3 will go to router 3. All right. Then packet 2, it will go from 2 to 5, and 3 will go from R3 to R4. Then packet 1 and 3, it will go through the R5, and 4, it will go through the R5. So based on the network layout, maybe we'll receive the packet out of order. We send it as 1, 2, 3, 4, but we receive them as 1, 3, 4, 2. All right.
So, I mean, the next message with the 4 frames, if it is sending from the sender to receiver, I mean, that time the message goes the same way like
No.
the first packet.
You don't know. So it's gonna send, the network will find the best path for you. And so you don't have a control. That's why in the connectionless, from the name, connectionless, you send, then you're out of control. You cannot control anything. You send it, network will handle it. So this message, again, it's win this path, but next time when you try to send, it's gonna be different path. So that's why we call it connectionless. And when it's out of order, what we have to do? So when after you receive all of them, you receive them as 2, 3, 4, 1. So what is the network layer responsibility at the receiver side? What we have to do? Or reorder the message, put the message together, and then pass it to the higher layer. Simple. So that is the connectionless. Why we use connectionless? That's the question, why? All right, so before that, let's give you this. So now each router will have a table, correct? Because based on the table, for each router will tell you which path you have to go. So for example, if you're trying to send a message from source to destination, and I'm trying to send it from A. So in the table, so that's my source address, which is host A. That's the destination, which host B. So what I'm telling the table, what's the table telling me? I'm trying to send to B. Which interface I have to use? I have to use this way, all right? So I have to use this path. And when you send it, okay, remember that's only one router. So this one, what this one is going to next hub. So what is the next hub? What's the option we have for next hub? Maybe it's another router, or maybe the destination, because maybe you're at the end. So that's it. So the purpose here, when you have the routing table is going to tell you if the source or the destination is B, you have to use this path, right? All right, so in the connection that's coming in the exam, the connection list packet switch, the forwarder, give me 1 second, guys.
I haven't looked. I don't know. It's been stock. What?
All right. So in the oriented list, who decide which path you have to go? The forwarding decision is based on the destination address, right? So if you're sending data to different destination, maybe it's going to go through a different path. All right, so that's in the connection list. So how's the speed? Why is the connection now? If I'm trying to send from A to B, so what you have to do, so you send the first packet to the router, correct? Router 1. Then the router 1 will wait for a small time. Do you know why the router has to wait for a small time? Because the router has to check which path I have to go. I have to read the table and find which path I have to use. All right. Then router 1 will forward the message to the next router. And what is the next router has to do? Wait for a small time, to check the table, which path, which next hub I have to send it to. Then, same thing, send it to the destination. All right. So after you finish delivering the message, what's gonna happen? Nothing, because you sent. I'm not waiting for anything to come back to me. And what is the total delay? It's going to be the transmission time. You add the wait time, another transmission, wait, transmission, until you send the whole packet. And that's only for one packet, correct? Now, that's the connection list. Now let's talk about connection oriented. What is the connection oriented now?
Depending upon the routers, we use like number of routers, the waiting time.
Which one?
Depending upon the number of routers, we
Of course, yeah. If the computer next to me, if it's a direct connection, you will not have any delay. Just the transmission. You cannot. That's why. Yes, there is an example. So if you're trying to ping a host, there is a function, there is a command called trace route. When you try that, it's going to show you how many hub you jump from. Let's say, trying to trace your route to google.com. You can go and type trace google.com. It's going to show you how many hubs you jump until you reach to Google and how much the delay for each hub. So it's dependent. If I'm trying to access a server within the campus, it will be only maybe 1 or 2 hubs. If I'm trying to access a website in India, It's going to be multiple, maybe hundreds, maybe you don't know, based on which path you have to follow. All right. So again, you cannot control that. However, the network should find the best path for you.
What is the router, the connection between routers and
That's, yes, you will have another path. That's why you will have, for example, now in your diagram, you can go through router 1 to 3 to 4 to 5. So for any reason, one of them went down, there is a communication. There is communication every millisecond between the routers. They update each other. Like, when I go down, because what I do, first of all, I have to check all the routers around me. When I know there is a router down, I will remove this router from my table because I'm not supposed to send them information. And not only that, when I know router X is down, I have to tell everybody around me the router X is down. So everybody aware, all right? So there is a mechanism. So that's why there's no issue if one of the routers goes down because there is another path you can use. All right. Before all the datagrams in the message can be sent. So that's the difference. You remember in the connection list, what you did, you just send the packet by packet. There is no any communication between source and destination. All right. I have a message. I divided 2 packets and I send one by one. I never talked to the destination. I did not tell the destination, I'm sending something to you. Now, in the connection-oriented is different. Connection-oriented, first, before I send anything out, what I have to do? I have to reach out to the destination, find the best path. So, for example, I'm going to New Jersey, all right? What I will do? I will go to Google Map and find the best path to go. And then I will follow this path. So same thing for the connection oriented. I'm trying to send something from A to B. First of all, I have to set up the connection. I have to go through the route, establish the connection. Then after that, the destination will reply back with a specific message, and I will show you now. Then after that, you send the message. Now, when you send the message, you follow the same path. You're not going to use different path. Since you decide to go through router 1, 3, 4, 5, all the packets is going to follow the same path. I have to go, all of them, they have to follow 1, 2, 3, 5. You cannot change the path. So first of all, we should set up and define the path for the datagrams. We have to know which path we have to follow. After the connection setup, the datagrams can follow the same path. I'm not switching. Then, in this case, you need not only the source destination and source and destination address, we need something called label, and we'll see why we need the label. We'll show you now. So, how many phases in the connection oriented? To send, there's the 3 phases. One, setup the connection. Second one, sending the message. Third one, tearing down the connection. So when I finish sending everything out, what I have to do, I have to tell all the routers I used, I'm done. So then they will delete the record. I'll show you now. All right. So it's not like connectionless. What we did, we just send the message. We did not really worry which path we have to go. Connection oriented, no. You have to set up the connection, send the message. Then after you finish, I have to tear down the connection. I have to tell everybody I finished, remove the record. All right. Just remind me. All right. So again, I'm trying to send a message from sender to receiver. Okay. First step, I have to go through the network, find the best path. So if I decide that is my best path, I establish that. After that, what's going to happen? Then you start sending all the packets through the same path. If you have packet 1, 2, 3, 4, all of them, packet 1 has to go this way, packet 2, packet 3, and packet 4. In this case, when we receive the packets, do you think these packets will receive out of order? It will be received in order. Why? Because when I send packet 1, all right, it's going to go this way, packet 2 is going to use the same path. There is no way packet 2 to be received before packet 1, unless if it's lost. If it's lost, that's different. Then we have to fix it. But the point here, in the connection-oriented, you will receive the packet in order, and you have to follow the same path. So simply, what we have to do, I'm trying to send packet 1, 2, 3, 4. Then it's going to go 1, 2, 3, 4. Then it's going to go through the router 3, 1, 2, 3, 4. Then it will receive 1, 2, 3, 4. Clear? Question so far? So again, let me just for the Zoom guys. So we send it 1, 2, 3 through the router 1. It will be 1, 2, 3 through router 2, router 3, then through router 4. So it will be received in order. Recording or no? Okay. So in the connection-oriented packet switch network, the forwarding decision is based on the label. We'll show you what we mean by that. So still, we need the source and destination. We cannot remove the source address and destination, so we need them, but we have to add a label to that. Why we need the source and destination? Why we need the source? Excuse me. Why we need the source and destination? If we're adding a label to the packet, why we need the source and destination? But we add the label.
Or like where it is and like delivery times.
No, the answer is here. Because even you use the label, maybe some of this router, they are using connectionless. You don't have a control of that. So you're trying to use the connection oriented, but maybe one of this router is limited to connectionless. We cannot use connection oriented for a reason. So that's why we have to keep the source and destination address. Now we'll show you how the path is going to go through it. It will be more clear, okay? So to create a connection-oriented service, we say the 3 phases. What we need: setup, data transfer, and finally, tearing down the connection. In the setup phase, the source and destination of the sender and the receiver used to mark table entities for the connection-oriented. I will show you the process. In the tear down phase, what you have to do: source and destination will inform the router that we are done. And what's the router will do? Delete the record, all right? Then data transfer occurs between the source and destination, all right? All right, so let's look about the labels. Okay, so remember in the connection-oriented, connectionless, what we said, the destination or the forwarding, it's based on the destination. So based on the destination, you can tell which port I have to go, all right? So in the connection-oriented, all right? So in the connection-oriented, so I'm trying to send the same data, right? However, what I'm doing, I'm adding a label. Why we need a label, you will know now. So I'm adding a label. So inside the routing table, I'm telling, label 1, if you have something coming from label 1, has to come port 1. And how this one will be exit? Has to go through the port 2. Simple. You don't have to worry about. And when it's exit, we'll have label 2. We'll know why now. So when it's exit, so when you forward it to the next hop, you add a label 2 to it. So when it comes with label 1. When it's leave the table, it's leave as label 2. All right. So let's now. Okay, I'm trying to send. That's how's the process happen. I'm trying to send a packet from A to B. So that's the data. That's gonna go through router 1. So what's router 1 will do? What's router 1 will do? Router 1 will say anything is coming from port 1, I will give it label 14, right? And then I will forward it through port 3. However, I will leave label for the out blank. We're not going to add anything yet, because the purpose here to find the best path. All right. So then the traffic is going to go, since we decide to use port 3. Since we decide to use port 3, now router 3 has to do something, has to build a table. What is the router 3 look like? So anything coming from interface 1, which label I will use? I will name it label 66. It's a random label, so we will say it's called 66. Okay, and has to go through interface 3, and the label is blank. I'm not going to add label. Why? We'll see why. Now, after that, the same message, I'm going to router 4. So the network decide we have to go here. So now R3 will has another entry. So R3 will add an entry again. What we did, we say anything coming through interface 1, I will give it label 22, and I will send it through interface 4. I will leave this one blank. Now, at the destination, what's going to happen at the destination? Okay, so now the destination, will go reverse to finish the tables. So now the destination will say now anything coming through me, I will give it label 77. Then what's going to happen here? I will add the 77 to the label there. Then the message is going to go back, and remember, because I already have it here. So I will add 22 there. Okay, same thing. It's going to go back. Now, what I have to add the label there? 66, correct? I will add the 66 to the table. Then finally, I will know anything coming through interface 3 has to go to interface 1, and I will use port 14. So what we call this one? What we just did? Did we send any data? Did we send a message? No. We just established the connection. So the network now find the best path. And now when you start to send the message, how you will send the message? So A will send a message, okay, we'll use label 14. When this router receives label 14, what this router will do? Well, label it and send it through here. So now this table, this router receive a label called 66. What I will do, I will know I have to send it through port 3, and which label I will give it? Label it to 2. Then the message is going to come here. I will know when the label is 22, what I have to do. Send it through port 4, and which I have to give. And when this device receive a message with label 77, okay, I will know that's meant for me. All right, we'll show you how. All right, so that's how now we are sending data. So I'm sending the source and destination, A and B. I will keep them. However, for now, I'm using the label. Label is telling me which path I have to go. So I'm sending bucket 1. I will know I have to go through interface 3, and then I will create a new bucket with label 66. So similar thing. What I will do, we replace the label with the 22, then send it to next hop. R4 will receive it, will know I have to add 77. Then You know, I know 77 is the destination. So what we did here exactly. First step, we established the path. Now all the packets will follow. If you have 100 packets, all of them has to follow the same path. All right. So that's why we call connection oriented. We establish the connection and we send it. Now let's look at the time. So what I have to do first step, I'm trying to send it from source to destination, establish the connection. How, remember, we went through the path first, then what we have to do, we have to go back. So now I created the labels. So now what we call that, the setup phase. Then what I have to do, send it. Now, why there is no delay here? Because the router knows which path has to follow because using the label. So there is no need to do anything, you know, just you have to read the table and send it. So you send it from router to router. Then after I finish sending stuff, what I have to do? Let's say, you know, I finished. What do we call that? What we call this phase? Tear down the connection. So what I do exactly in the tear down connection, what I'm doing? Just I'm telling all the routers next to me, I finished, and they will delete the record from that. So now a question for you. A question for you guys. If I'm using label here, why I need A and B? Why I need the source and destination address? Since I'm using the label, The label is telling me which path I have to go. Why I'm using, still I need the address, source and destination.
To set up the path. To set up the connection.
The router needs to know that from where the message is passing.
So you need it for setup connection, but the other reason, second reason, sometimes one of these routers, maybe it's connectionless. So if you're trying to use this router and this router is connectionless, so the router still needs the source and destination to be able to communicate, all right? So that's one of the reasons why we need the source and destination address here. So that's the question in the exam. All right? Guys, let's take a break for 5 minutes. Not much left. Today it's going to be a short class. 5 minutes, come back.